Space is full of wonders. From the twinkling stars that dot the night sky to the vast, mysterious galaxies that stretch beyond our imagination, the universe is a treasure trove of marvels waiting to be discovered. We look up at the stars and imagine what might be out there. Are we alone in this vast expanse, or is there life on other planets looking back at us with the same sense of wonder? Could there be planets like our own? Planets with oceans, mountains, and perhaps even life forms that we have yet to encounter? Or are there strange worlds unlike anything we can imagine? Worlds with landscapes so alien that they defy our understanding, with elements and compounds that are rare or even unknown on Earth? In the constellation Cancer, there is a star called 55 Cancri. This star has captured the attention of astronomers and scientists for a very special reason. Orbiting this star is a planet called 55 Cancri e. This planet is special. It's not just another rocky world, it has unique characteristics that set it apart from the rest. It's been called the Diamond Planet. This nickname isn't just for show, it hints at something truly extraordinary about this celestial body. Why is it called the Diamond Planet? The answer lies in its composition. Scientists believe that 55 Cancri e might be made largely of carbon, and under the extreme pressure and temperature conditions, this carbon could exist in the form of diamond, because scientists think it might be made of pure diamond. Imagine a planet where the surface glitters with diamond-like reflections, a world where the ground beneath your feet is made of one of the most precious materials known to humanity. This planet is twice the size of Earth and much, much denser. Its mass and composition suggest a world that is incredibly rich in carbon, making it a fascinating subject of study. Imagine a giant diamond floating in space. It's a vision that seems almost too fantastical to be true, yet the evidence points to this incredible possibility. It's a fascinating idea that captures the imagination. The thought of a planet made of diamond challenges our understanding of planetary formation and the diversity of worlds in our universe. But how did this diamond planet form? What processes led to the creation of such a unique world? Scientists are still trying to unravel the mysteries of 55 Cancri e, and could it really be true? Let's find out. Join us as we explore the wonders of the universe and uncover the secrets of the Diamond Planet. 55 Cancri a is an exoplanet, a fascinating world that lies beyond our solar system. That means it's a planet that orbits a star outside our solar system. These distant worlds are incredibly intriguing because they offer a glimpse into the vastness of our universe and the potential for other forms of life. It's very difficult to see exoplanets directly. They are often hidden in the glare of the stars they orbit, making them elusive targets for astronomers. They are small and faint compared to the bright stars they orbit. This contrast in brightness makes it challenging to detect them with traditional telescopes. So how do we know they are there? The answer lies in the innovative techniques developed by astronomers over the years. Astronomers have clever ways of finding these hidden worlds. They use indirect methods to infer the presence of exoplanets. One way is to look for a wobble in a star's light. This technique, known as the radial velocity method, has been instrumental in discovering many exoplanets. This wobble is caused by the gravity of an orbiting planet. As the planet moves around its star, it exerts a gravitational pull, causing the star to move in a small but detectable way. As the planet goes around the star, it pulls on the star very slightly. This gravitational interaction creates a subtle movement in the star's position. This makes the star move back and forth. By carefully observing this motion, astronomers can deduce the presence of an exoplanet. We can see this movement as a shift in the star's light. This shift, known as the Doppler effect, provides crucial information about the exoplanet's mass and orbit, helping us understand these distant worlds better. In 2004, astronomers used this wobble method, a technique that detects the gravitational pull of a planet on its star, causing a slight wobble in the star's position. This method led to the discovery of 55 Cancri e, an exoplanet located about 41 light-years away in the constellation of Cancer. They found that this planet orbits its star very closely, much closer than Mercury orbits our Sun. It takes just 18 hours for 55 Cancri e to complete one orbit. This means that a year on this planet is less than a day on Earth. Imagine living on a planet where you would celebrate your birthday every 18 hours. The concept of time would be entirely different. Scientists were able to learn a lot about 55 Cancri e by studying its orbit and the light from its star. By analyzing the light spectrum, They could determine the planet's composition and other characteristics. They calculated that it is about 8 times heavier than Earth, making it a super-Earth. This means it has a much stronger gravitational pull. They also figured out that it must be incredibly hot, with a surface temperature of over 2,000 degrees Celsius. This extreme heat is due to its proximity to its star, but the most intriguing discovery was its possible composition. The data suggested that 55 Cancri E might be a carbon-rich planet. The planet seemed to be made mostly of carbon, which could mean it has vast deposits of diamonds. This is because under high pressure and temperature, carbon can form diamond structures. Imagine a planet with a surface glistening with diamonds. This discovery has sparked the imagination of scientists and the public alike, as it challenges our understanding of planetary formation and composition. The study of 55 Cancri E continues to provide valuable insights into the diversity of planets in our universe. Each new discovery brings us closer to understanding the vast and varied nature of planetary systems. As we look up at the night sky, we are reminded of the endless possibilities that lie beyond our own solar system. The universe is full of wonders waiting to be discovered. Carbon is a very versatile element. It can take many forms. On Earth, we know carbon in its soft form as graphite, the material in pencils. But under extreme heat and pressure, carbon atoms can bond together in a different way. They form a crystal structure that is incredibly strong and brilliant diamond. Scientists theorize that the intense pressure and heat deep inside 55 Cancri E, combined with its carbon-rich composition, could create the perfect conditions for diamond formation. Imagine that, a planet with a core of solid diamond possibly surrounded by a layer of pure graphite. This incredible idea is what earned 55 Cancri E its nickname, the Diamond Planet. Section 5. A second look. The idea of a diamond planet captured the world's imagination, but, science is all about testing ideas and refining our understanding. As technology advanced, astronomers were able to study 55 Cancri E in more detail. They used more powerful telescopes and new techniques to observe the planet and its star. These new observations provided more data, and with more data, scientists can refine their models and theories. They found that the planet might not be as rich in carbon as initially thought. The ratio of carbon to oxygen, another important element, seemed to be lower than previously estimated. Section 6. A planet of extremes. Even though the diamond planet theory is now less certain, 55 Cancri E remains a fascinating and extreme world. Its tight orbit around its star means it's tidally locked. One side of the planet always faces the star, just like one side of the moon always faces Earth. This results in a dramatic temperature difference between the two sides. The star-facing side is a scorching inferno, hot enough to melt rock. The other side is shrouded in perpetual darkness. The planet's atmosphere is also likely very different from Earth's. It could be a thin, hazy atmosphere composed of vaporized rock and minerals. Section 7. Unlocking the secrets. The James Webb Space Telescope, the most powerful space telescope ever built, is now setting its sights on 55 Cancri E. This incredible instrument can analyze the light passing through the planet's atmosphere when it passes in front of its star. By studying this light, scientists hope to learn about the composition of the planet's atmosphere. They are looking for clues about what elements and molecules are present. This information will help them understand the planet's formation and evolution. It might even reveal whether 55 Cancri E has clouds, volcanoes, or even a hidden, molten surface beneath its thick atmosphere. Section 8. More than just a diamond. While the diamond planet theory has been challenged, 55 Cancri E continues to fascinate and inspire. It reminds us that the universe is full of surprises. It shows us that even the most seemingly outlandish ideas can sometimes have a grain of truth, even if they need to be revised and refined as we learn more. The story of 55 Cancri E highlights the ever-evolving nature of science. It's a process of discovery, questioning, and refining our understanding of the cosmos. Section 9. A universe of possibilities. The search for exoplanets like 55 Cancri E is just beginning. Every new discovery brings us closer to answering fundamental questions about our place in the universe. Are we alone? Are there other habitable worlds out there? Or are there countless other strange and wonderful planets waiting to be discovered? The universe is a vast and mysterious place, And as we continue to explore, we are sure to find more wonders that challenge our imagination and inspire us to keep searching for answers among the stars.